Hello guys, welcome back. So objective of today's class is that we are going to learn what is logical address. We can call it as the IP addressing mechanism, and why we require this IP addressing mechanism. So once it is completed, we are going to see what are the different type of IP addresses we will be having. One is nothing but the version 4, another one is nothing but the version 6. What is the difference between IPv4 versus the IPv6? Once it is completed, we are going to see that what is the address space of the IPv4. Once it is completed, what are the different types of the classifications of the IPv4 addresses we are going to see in this today's lecture. So first, if you try to read these statements, communication at the network layer. So network layer means in the OSI model, the L3 layer 3 is nothing but the network layer, right? So is host to host, nothing but the, you can consider as the system to system or computer to computer, right? A computer somewhere in the world needs to communicate with the another computer somewhere else in the world, right? So we want to communicate with one computer with the another computer, right? So in order to communicate one different network to the another different network, we need something called as the unique addressing mechanism, right? So we need something called as the global addressing or unique addressing mechanism. This is what we called as the logical addressing. We can call in terms of the IP addressing, right? So what is the meaning of this one is the device may be within your network or it may be different network. Suppose for example, see that if you want to communicate one mission with the another mission, we require something called as the unique identification mechanism. That is what we called as the logical addressing or IP addressing. Suppose for example, see the moment if I take the packet here, right? So if I'm trying to communicate from this device to the this device, now see that it is not showing, right? PC1 has no functional port, right? For that, what we have to do here is that first we need to assign some addressing mechanism. So see that this is the device. So the moment if I giving something unique addressing mechanism, some IP address I'm giving, so 1.2 something I'm giving. Now see that this is the subnet mask. Later on we will discuss what is the all about subnet mask, default gateway as well as the DNS server. Now this is the unique addressing mechanism we have given for this one. Then one more important point to remember is that so IP address is globally unique. It means that IP address is unique. So one assigned IP address cannot be used for the any other device in the mission in the network, right? So that is what all IP address are the unique, right? Now for example, suppose you will be understand what is the meaning of the unique mechanism. Suppose what is the IP address here I have gave 192.168.1.2, right? Suppose the moment if I am trying to give here also, this is my second mission. Suppose what is the IP address earlier I have used 1.1.2, right? Suppose if I give again 1.2, what it is showing, this address is already used in the network. It means that each IP address in the network should have the unique identification. So if you are trying to give the duplicate IP address, it will not accept. So from this conclusion, you need to understand that each IP address will be assigned to the only one device, right? So that's why you can able to communicate one device with the another device by using of the IP addressing or logical addressing mechanism. Now see that if I'm giving some other IP address, we can able to communicate from the one mission to the another mission, right? So now see that usually computer communicates through the internet. The packet transmitted by sending computer may pass through the several local area networks or wider area networks before reaching to the destination computers. It means that from your source mission to the destination mission, there may be n number of routers, n number of switches, nothing but L2, L3 devices, right? So all these mechanism it has to pass, then finally it need to identify where is your destination device is located. So for that we require something called as the unique identification mechanism. That is what we called as the IP addressing mechanism, right? Now we'll see that what is the length of the IP address, right? So the length of the IPv4 address is the 32-bit length, right? So total length of the IPv4 address is 32-bit. So it means that so each will be again it will be divided into the 4 8-bits, right? 4 8-bit means that 4 octets. Each octet will consist of the 8-bit representation, right? So 4 into 8 is nothing but the total length will be 32-bit representation. Each octet will consist of what? 8-bit binary information, right? So now question is that how many maximum number of the IPv4 address we will be getting. So IPv4 means this is the version 4. So what is the length of IPv4? It is the 32-bit length. Now it is a 32-bit length. If you want to communicate one device to the another device, that means that in the world each and every device will be identify its own unique identification mechanism. That is what we call as the IP addressing. No two devices should have the same address, right? So see that two devices on the network can never have the same address at the same time. Now how many maximum number of IP address we will be getting is that if some n is your number of the input, then total number of possibility will be represented by in terms of the 2 power n. Suppose for example if 2 is your input, then total number of possibilities 2 power 2. It means that we will be getting the maximum of the 4 possibilities, right? Now as per our discussion, IPv4 is the version 4. The length of the IPv4 is the 32-bit. So how many maximum number of address we will be getting? 2 power n. So it means that 2 power 32 we will be getting the something around the 4 billion IP address. So it means that we have the 4 billion unique IP address. By using these 4 billion unique IP address, I can able to assign to the 4 billion n devices so that they can communicate happily from one device to the another device. So address space means total number of addresses that we can get for the IPv4, right? Now see that the address space of the IPv4 is the 2 power 32. This is the count we will be getting the unique IP address, right? Now see that we have the two classification. One is IPv4, another one is the IPv6. Version 4, version 6. The length of the IPv4 is 32-bit. The length of the IPv6 something 128-bit representation. So once we completed IPv4, then we will discuss about the IPv6. What is the need of IPv6? Why we are going to the IPv6 instead of IPv4? Later on we will discuss. Now the one more important point is that what are the notations or representation of the IPv4 address? The IPv4 address is 32-bit length, right? So we can able to represent either in terms of the binary notation or it in terms of the dotted decimal notation. So if you see that in my packet tracer scenario, I have shown some IP address, right? 192.168.1.2 something, right? So if you want to, either you can represent in terms of the binary representation or you can represent in terms of the dotted decimal notation, the 32-bit number. See that as I told that 32 will be divided into the 4 octets. Each octet will be consisting of the 8-bit representation. This is one way to represent the IPv4 address in terms of the binary number. Now we will see that how to represent the IPv4 address in terms of the dotted decimal notation, right? Suppose for example, see that this is my binary number, this is what in terms of the dotted decimal notation. So what is the meaning of the dotted decimal notation? Means we have the 4 octet, right? So 4 into 8 is nothing but the 32, right? After each octet we will be having the something called as the dotted representation. This is what we called as the dotted decimal notation, right? So for example, if you want to convert this binary number to the decimal number, you should have idea about the how to convert the given binary number to the decimal number system, right? If you don't know, let me give the formula so that you will be understanding, right? So we have the binary number system formula for integer part r power 1, r power 2, r power 3 and so on. So it means that for binary number system, so here what is the r value is that r value equal to 2. What is the meaning of r is radix are base value. So what is the meaning of radix or base? How many number of bits which are used in the particular number system. In case of binary number system, we have 0 and 1, 2 bits, right? So for a binary number system, r equal to 2, right? So just substitute the value 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4 and so on, right? If you are writing in terms of what? 1, something like 1, 2, 4, 8, 16, 32, 64, next 128. See, each will be consist of the 8-bit representation, right? So I am writing everything in terms of the 1, 2, 3, 4, 5, 6, 7, 8-bit representation. Now see that what is this number? What is this number? Something 1, 0, 0, 0, 0, 0, 0, 0. Now see that in the 128 place we have 1, right? So the answer is 128. So like this, by using this code we can able to find out the decimal to binary or binary to decimal number system, right? Now suppose for example, what is the meaning of this one? 1011, right? So 1011, these are all the 0. So it means that 8 plus 2 plus 1. So 8 plus 2 plus 1 is what? Right? So 10 plus 1 is nothing but the 11. So this means 3. So like that we can able to convert in terms of the dotted decimal notation, right? Suppose for example, you want to write the, let it be your IP address is something like this, 15.1.1.10 something. Then how to write this one? Each will be represented by the 8-bit number, right? So it means that 1, 2, 3, 4. What is the binary number for 15? This is the binary number. So this 8-bit consists of the number of 15 in case of the binary representation. Next is what? 1, right? So 1 means in terms of the 8-bit representation, right, we need to write the 7 zeros followed by 1. Again 7 zeros followed by 1. So 10 means what is the answer? 0 0 0 0 6 ones. Next 1 0 1 0, right? So like this we are going to write in terms of the binary to the decimal or decimal to the binary, right? So in exam point of view, might be expecting the short questions that replace each 8-bit with the equivalent decimal number, right? So for example, this is my number. What is this value? So this is 128, right? This is 1, right? So it is means that 128 plus 1 is nothing but the 129. So how to substitute means 1248 16 32 64 128. What is the given value? 1 6 zeros 1, right? 1 6 zeros 1. So what is this value? 128. Here we have the 1, right? So 128 plus 1 is nothing but the 129. See that it is replacing with the dotted decimal representation in terms of the 129. So like this we need to find out the value, we need to find out the value, we need to find out the value. If you remember this logic, you can find the decimal to binary or binary to decimal number system, right? So these are the two ways to represent the IPv4 addressing mechanism in terms of the 32-bit length. Now see that we will find the what is the errors in the particular sequence. We have the A, B, C, D. We need to find out what is the error in the A, B, C, D. Now try to guess what is the answer for this one. Where is the error we have? Just try to find out. So where we have the error here, where we have the error here, where we have the error here. So we will try to see the answers, right? Now first thing is that there must be no leading zeros. So what is the meaning of this one is, if you are writing the 4 8 bits, right, 1 2 3 4 in terms of the dotted decimal notation, right, each octet will consist of the 8-bit number. So what is the meaning of 8-bit number means the total number of possibility 2 power n. It means that 2 power 8 is nothing but the 256. The binary number starts from the 0 and ended with the 255. It means that each octet value should consist the number which is in between to the 0 to 255, right? Now see that we have the triple 1. So triple 1 is in between 0 to 255, right? It is okay. 56 also in between 0 to 255 in the second octet. It is also correct. But here if you see that it should not be no leading zeros. It means that if you want to write the 45, we should write only 45. We should not write something 045, 012, like that we should not write when you are representing the version 4 IP address. Now try to find out what is the error here. Now see that how many octets we will be having? 4 octets. As per this B, how many octets we have? 1, 2, 3, 4, 5. So this is the wrong answer. There can be no more than the 4 numbers in the IPv4 address. Now what is the wrong here? See here we have the 301. What is the maximum value? In between 0 to 255 only, right? 8-bit representation means. So this is the error here. Now here what is the wrong here? If you observe here, this is also correct, this is also correct, this is also correct, but this is also in terms of the binary number only. But thing is that you cannot mix with the, right, it means that you cannot mix binary number with the decimal representation or decimal representation with the binary number. It means that if you are following the binary notation completely, it should be in terms of the binary notation, or it should be completely in terms of the dotted decimal notation, right? So these are the sum of the errors, right? So in the next class we will see what is the different types of the classful IP addressing